Hello, everyone, and welcome to this session on testing hypotheses. And today we'll be looking at the powerful tools used to analyze data relationships and test assumptions statistically. And for this lesson or this class or training, as the case may be, we'll be looking at correlation, t-test, and analysis of variance. I'll create time to do another session that will be basically on chi-square, and if opportunity comes, I will include regression analysis. Um, Before we continue, I want to quickly emphasize that I have made this session to be very beginner friendly, like very beginner friendly. I have tried to use clear examples so that you'll be able to understand this concept. So I'd like you to please take note as you listen along. Meanwhile, like I've always said, there is lots more. There are more researches you can do. I can't cover every field of endeavor. We are from different field of endeavors. Some of you are in education, some of you are in sciences, some of you are in social science, business, and the likes. So you have to just keep looking out for how this training can be relevant to your area of interest. So without much ado, let's quickly dive into what we have today, and that is hypothesis testing. A quick one before we begin whatever we need to do generally. So what is hypothesis testing? Now, hypothesis testing is actually a statistical method that we use to determine whether an assumption or hypothesis about a population parameter is supported by evidence in your data. Like we have always emphasized, it's all about data now. Yes, it's all about data. So if you make a statement, opinion, whatever, you have to get data to back it up. It's just like you're in a courtroom trial. Everybody must bring their evidence together in order to support or reject a claim in the court. It is the evidences before the judge that the judge will use to make conclusion on the matter. And an example is, let's say a school principal claims that, okay, oh, students who study in the morning, they score higher than those who study at night. We need to put this to test. We cannot just agree to the principal statements. There has to be data. We need to bring data to board to be able to take decision or to be able to say, okay, we encourage students to study in the morning or night because we have observed that those who study in the morning or at night, they do what? They get better grades. So it's not just about that. The same thing in business. You cannot just sit down and think, oh, and that's the mistake a lot of business people do, especially small, medium enterprise, because they don't have data. They see this person doing it, they just join it to do the person to do the business, whatever the person is doing. Oh, this woman is selling this, they join the woman to sell it. This man is selling this, they join the man to sell this. No, it shouldn't be like that. You need to be able to have backup to be sure that, okay, if I start to sell this, my patronage will still continue. Is this what I really need to sell? Is this product what people are actually looking for right now? Is it because I just observed that one, two, three people, I saw one, two, three people coming to buy it? I'll not believe that, oh, it's like people are buying this thing. No, there has to be sufficient data over time before we can make that conclusion. So very important. Now, the key terms we'll be talking more about or we'll be mentioning and in the course of this training is we have null hypothesis, and that's the default position stating that there is no effect or no difference. Example, morning and evening study times have no effect on scores. That's a null hypothesis. Now, alternative hypothesis is just like the opposite of the null hypothesis. Is a claim test. Is suggesting that there will be a significance difference. like morning study leads to higher score, or you can say that night study leads to higher score, or afternoon study leads to higher score. What you are doing is you are refuting the claim by the null hypothesis that there will be no significant effect. So the alternative hypothesis is telling us that there is actually a what? Significant effect. So that is what we're talking about. So without much ado, let's quickly delve into the first one we'll be looking at today, which is what? Correlation. Now, I'm giving us this graph for us to have an idea of what correlation is actually about. You can see from the first graph, we have a straight line graph there, and is moving, let me say, away from the graph. So that first one is a perfect correlation because the line is very straight. Then the second graph, where you move to your right hand side, the one in the middle on the right or at the topmost part, strong positive correlation. Then we have the weak positive correlation. So you notice that it's moving towards away from the graph in a straight line form. Now, if you look at the one in the middle, right in the middle, that we have no correlation, you can see that all the dots are scattered. All the dots are scattered, and that indicates that there is no correlation. All of them, they are just on their own. They don't have any relationship. But the graphs at the bottom part, you can see is the other way around, is like the opposite of the one on the top part. So that is what? A negative correlation. We have the weak negative correlation, strong negative correlation, and perfect negative correlation. Now, what do these, how do we explain this, and how do we get to find out this type of correlation in statistics? Now, correlation is used to test how closely two variables are related to each other linearly. That's very important. We look at it. What will happen to one if we increase one? Is will the other reduce or increase? For those of us who did proportion in maths, that's more like it. If you increase this, what will happen to the other? If you reduce, what will happen to the other? That's talking about correlation. And it is usually used to describe linear relationship, but it does not mean causation or effect. What are we trying to say? That it doesn't mean that that is what caused it. For example, now you cannot say that because uh, because there's a relationship between the number of hours they study and the test score. You now say that it's the number of hours they study that cause or that bring about the test score. Not really, not really. It's just a relationship, not causation. That's what we are trying to say here now. Now, a positive relationship between variables implies that an increase in the value of one variable will tend to go with an increase in the other variable, and the other, and that's vice versa too. To be vice versa. So if you say two variables are positively related, it simply means one increase, the other increase, or one reduce, the other reduce. That's positive relationship. Now, another important concept we can bring to board whenever we are discussing correlation is the concept of the scatter plot. This um, diagram, or the diagram we are seeing here, is actually a scatter plot. The scatter plot is just showing us the direction of the relationship, whether it is positive or negative, or whether there is no relationship. So scatter plots can give us an idea of what we expect whenever we do correlation on two variables. Now, scatter plot is a visual tool that can be used to depict the relationship between two quantitative variables, but it is difficult to determine how genuine the relationship between the variable is through scatter plot. So we're just going to do an example of scatter plot using some data that I have imputed on the SPSS. So this is these are some of the data that I have inputted in the SPSS. I just want to use this for the purpose of this class alone. So you can see I have hours study, test score, then I have groups, group 1 and group 2, I have scores too for each of the group. Then I have I'll, as for all the analysis I will do today, I've imputed some of this data here so that I'll be able to use them to explain. But for the moment, what we want to look at is just the scatter plot. So we just go to graph, we select legacy dialog, then select the scatter slot dot option. We click on the sample scatter plot and click on define button. Then we use the arrows to select the dependent variable and place it in x-axis and y-axis. Then we click OK. So this is just what we need to do to be able to do scatter plot. So we want to do scatter plot for hours of study and test scores. So let's come to graphs, legacy dialog, scatter dot, scatter slash dot, we select. We want to use just simple scatter. Yes, you may also ask question, what are others for? Yes, that's why it's a risk. That's why you are a student, so you can just go, or you are training to learn more. You can do your own personal research. It's a computer, so you can always try and do as many things that you want to do. You can always undo if what you have done is not satisfactory. So we select simple scatter, then we define. So yeah, we want to look at, okay, these are some of the things I've done. We want to look at um what we need to um, do the scatter plot on. So we want to do for hours of study and test score. So I'll select my hours of study, I'll put it on y-axis. I'll select my test scores, I'll put it on x-axis. So these are just for other form of um, um, things we need to do, set markers, label cases, and so on. So that advanced option, which you may want to know more about later. But for the purpose of these studies, this is set, this is okay. So click OK, then we'll check our output. Of course, whenever I click analyze something, the output will just pop up immediately. So let's have OK. So let's see what is bringing up. So you can see this is the output is bringing up. So now if you look at this and you compare it with any of these, you'll be able to determine the kind of relationship. So you can see, look at this, and I believe it's related to this. So you can say there's a strong positive correlation. So this is just a guess from the scatter plot. So we will now do the actual correlation so that I'll be able to know how strong the correlation is and be able to do the correct interpretation as the case may be. So now let's move on from here. So that's that about the scatter plot. So now correlation, another important concept in correlation is outliers. So whenever I do correlation, usually there is always one or two dots. Let me not say usually, in some cases actually. In some cases there might be one or two dots that will just be far away from every other dot on the graph. Yes, this is possible. When you see it like that, we call that an outlier. For example, now, if one student score exceptionally high, despite that the student has low study hours, you can imagine. And is a, of course, is what we see every now and then. There's a possibility maybe the student is a very smart student or an experienced student who just find himself in a lower class. So the student may not really study much hours time because he already has all those things in his memory. But then it could score higher, so that is an outlier, which is always happening. We always see it in experiments, so it's okay. It's not a crime when it happens that way. It's just that we should be able to, like I always say, you are the data analyst, you are the specialist. You should be able to talk to your audience or your stakeholders what you mean or what happened or why the data looks like that. All you need to do is learn how to communicate your date your story with people about the data, and that will be able to clear their doubt. So now another concept or term we need to talk about is a curved linear trend. Like it may not always just be straight line. There could be trend that the line will be curved, but then there's a relationship. So it's not always straight line all the time. So that's just a point to note. Now, when we talk about correlation, the most common correlation that is being used is the Pearson product moment correlation coefficient, and this helps to determine if the relationship between two interval or ratio variable is significant by chance. You see, I keep emphasizing this level of measurement at every training session, and it's actually very important. we must always review, revise, and retain it in our memory, because it is what will actually guide us to be able to use the right analytical tool whenever we want to do analysis. So help to determine relationship between two interval or ratio variable is significant by chance. Then it also helps to determine the direction and strength of relationship between the two quantitative variable. You see that's coming again. Then the correlation coefficient values ranges from +1 through to 0 to -1. So if it is +1, that means there is a perfectly positive correlation. If it is 0, there is no correlation, and if it is -1, there is what we call the perfectly negative correlation. However, if it's fall in between +1 or 0, we say there's correlation. Then if it's close to 1, it's strong. If it's not far away from 1, it's weak but positive. So that is how we just get to interpret it. And okay, we have to go for another example on SPSS now, how to do correlation with SPSS. So I'm going to use the same value that we just used before. Now we're also going to use that to explain our correlation. So I will come to we can do it right, we can do the analyze from here straight away. Correlation, where is correlate, bivariate, yes. Then we'll select our values. I think I have done some work on the system, so it's stored it. So select what we want to correlate. You can do it from here, and can also do it from the the variable view or data view, as the case may be. So let me come to the data view so that it will be easy for those who are still trying to have their feet strong on SPSS. So bivariate, then we have the we're going to use the, you select your test score, and you also select your hour studies. Where is hour studied? Select hour studies. Then we are using the Pearson moment product correlation. Then we use two-tailed, and we're not using one tail. I'll come back to explain what we mean by two-tail and one tail. So the basic difference is that two-tail is saying that I don't know the relationship before. So just open my eyes to see why one tail is trying to say that, oh, there's actually a relationship, but I want to know, is it positive or negative? So that's just it. So I click my OK and see what it's going to bring out. So this is what it has brought out very fast. Correlation, and this is the table it brought out. So you can see this is the test score, our studies. So it's the end says the total number is 60 and the best correlation 1, but then this is what we have 0.985 and significant at 0.00, and we have for study hours 0.985, significant at 0.00. So we can see that from this table, what we can take note is that the correlation is very strong, and that's also depicted from the graph. It's also depicted from the graph. So the correlation is very strong, and it's positive. Yes, it's strong and it's positive. So the direction of the relationship is positive. So the correlation between um, hours of studied and test score is 0.985, and this is very close to 1, and that indicates a strong positive relationship. So it simply means that as the hours studied increase, test scores also increase in a linear pattern, like in a straight line. So we can see the significant level to be 0.00, and it shows that the significant level is actually very high. So the correlation is statistically significant at 1%. Even at 1% is significant, even though we often use 5% as significant level. But in this situation, at 1%, it is significant. So it simply means that there is less than 1% chance that this result occur due to random variable. Like it's not like it just happened like that. 99% of the time, it simply means that this is the kind of result we're going to be seeing 99% of the time. That's what this particular statistical data is trying to tell us. So that means a strong relationship exists between the variable at this significant level. So if we are meant to like state an hypothesis now, we can say that The results showed a very strong positive relationship between the hours studied and test score, and that's statistical significant. This implies that as students spend more time studying, their test score tend to increase significantly. So if somebody stated a null hypothesis that there is no significant relationship between hours of study and test score, so these results will make us to reject that null hypothesis and accept the alternative because there is actually a significant relationship between them. So that is that about the test and the interpretation. So now what we just did is the I beg your pardon, correlation and the interpretation. So how do you do correlation? Okay, we just did that now. So point to note, I've mentioned that too, but let me just read it out again. When two-tailed or one-tailed test is selected, then SPSS assume that you do not have any idea about the direction of the association between the variables when two-tail is selected. So selecting one-tail test on the other hand implies that you have anticipated before and like you know that there is actually either a positive or negative correlation between the variable of interest, but then you want to test to see if this correlation between them is statistically significant. So that is that about um, correlation. I'll see how I'm going to set up more questions on correlation for us to be able to do, and I'll send it to us in our mailbox. And for those of us who are watching online, maybe you can check the link below to be able to see the um, tools or the data you can use to test for your own correlation. So let's move on to the next one, which is what t-test. T-test. Now, one of the tasks we do in our previous training and it's also on one of the videos, we looked at we did what we call compare means. We just did compare means, like they ask us to find us the average mean in different groups, and we use one of the statistical tool to do what we call compare means. So that's exactly what it test does. Is used to test whether the differences between the means, like the average of two groups, are statistically significant. That is what it does. We want to see, okay, these two groups, they have done a task, and after doing the task, this is their score. For each of the group, find the average, find the mean. Now, after finding the mean, check for us, is the difference between them significant or not significant? That is exactly what it does. For example, do males and female differ in test scores? As an example. And for this t-test we're talking about two types of t-test, which is the independent t-test, which just does compare means between two unrelated groups like class A and class B. Then we look at peer t-test, which compares the means between two related groups of measure. For example, you want to check if there's a difference between blood pressure before and after taking a particular medication. So you check the blood pressure at first, then you give medication, then you check the blood pressure later. Then you now check, is there a significant difference between the results you get after between the results of or the blood pressure before the drug or and after the drug. So those are the two. But generally speaking, requirements for the t-test is that the independent variable should be nominal or categorical. You can see level of measurement coming in again. Why dependent variable has to be interval or ratio scale of measurement. And the population from which the two sample groups are drawn can be independent or matched, like they can be separate or related. So that is that about it. Now, independent t-test is used with unmatched data. It's also known as t-test, and you just test for two independent means. We're going to see that in a moment now. Now, requirements, we just talked about a categorical independent variable with two distinct categories like group A, group B, male and female, boys and girl, class A, class B, or school A, school B, or business A, business B, and things like that. So, and whatever you measure, whatever you the dependent variable that will be measured has to be either in interval or ratio level. Like it should be a number that you can continue to read upward, like 1 2 3 4 5 6 to and above. So it shouldn't just be a number that is just nominal, like you just gave it. It doesn't mean there is an increase or reduction in the value of the number. So okay, I've talked about the independent t-test, then the peer sample t-test that we talked about, also known as t-test for related measure, then correlated t-test or related t-test. So it tests if there's a significant difference in the means of each of the paired samples of variables. So what you need to be able to use the peer sample t-test is there has to be matched data where repeated measurement of responses were collected from the same respondent. So remember the blood pressure example I used. You check the blood pressure at first, then you administer a drug, then you check the blood pressure again. So you can see that health people, they use a lot of this data too, and that will be able to determine if they will ask the patient to continue with either two dose or to drop it to one dose or to even stop using it based on check if there's a significant difference. So data might be collected on a single or different occasion, such as before and after studies or experiments. So now let's see how we can conduct independent sample t-test in SPSS. So to do that, we'll come to our data too. So what I have here is I want to use these group scores, group and scores. So I have a group here, 1 and 2, actually A and B. Let's check my variable. So my group is, we have, yes, group A and B. A is 1, B is 2. So that is it. Then we have their scores. Their scores is numeric, yes, and is on the scale measurement of level height, ratio and interval. So now let's see how we can carry out the independent sample t-test. Let's look at the step we need to take. As usual, we go to analyze. We'll select compare means from the list of menu. Then we'll select independent sample t-test from the compare means drop-down list. Then we'll transfer the dependent variable to the test variable box. Then we'll transfer the independent variable into the grouping variable box, and we'll define the two variable groups. So let's see how we just do this quickly. Then we come to analyze, compare means, independent sample t-test. So good. Okay, excuse me, please. Oh, I will have done all this before now. Sorry about that. So now the test variable we are looking at is scores. So I'll come and select my scores. Then the grouping variable is also is group. So I'll come here, select the grouping variable. Then I have to define it. Define in the sense that my group one that I've imputed in my data, that's group A. Then group two, that's group B. Then I'm going to continue. Then I'll come here and select OK. Let's see what comes up. Okay, very good. We have this table coming up. We have two tables here. The first table is just a descriptive statistics, and the second table is where we're going to get our independent sample to test. Now you can see there are a lot of information supplied. So the table gave us so many information, but then that is no, we don't need everything. So we just have to select the one that is peculiar for us. However, different research groups or different faculties in the university, different journals, for those of us that are researchers that will be writing paper, different groups, they have their way of presenting the table for each of their statistical tests. So we need to just consult. For example, I'm aware there is APA format, there is the format for Harvard, there is that for MIT. So different groups will come up. In fact, different universities, even in some universities, the different faculties will come up with their own idea or their own way of presenting the table. So you need to find if you are doing a project or you want to write an article for publication, you need to find out how the group you are writing the article for will present the tables of their hypothesis. Then that will guide you on how to go about it. So the group statistic, which is just basically the measures of central tendencies, I can see this is the mean, the standard deviation, and the standard error of mean. So let me just quickly do a simple description of each of the key terms. So in this situation, where we're comparing the two group scores. That's what we're comparing. And you can see the group statistics table will show us the number of each of the group. So basically there are group A and group B, which give us, you can see group A here and group B here, and each of the number represented in the group are 30 30. So the total number is what? Is 60. And this is the mean of each group. That, remember that t-test is comparing means to check significant difference. So this is the mean of each group. So for this group we have 74.7724, and group B we have 69.6962. So that is the mean. Then we have the standard deviation, and what does it do? It tells us how spread out the scores are within the group. So the spread out of the score within the group, we have the standard deviation of 9.98 for group A and 8.75 for group B. Then we also have the standard error of the mean. I'm just trying to explain this for us to understand. But when we are doing our reporting, all this may not be necessary. You can just go straight to your point, since what you need is just the t-test and the significance, and you can be able to make your conclusion based on the significance level. So what we have here for the standard error of the mean is just measure how precisely the sample means estimate the population mean. Like the this each of the sample, the mean, the average, or how should I put it now, how the sample mean estimates the population of the mean. Okay. Then we now have the independent sample test table. And for the independent sample test table, we have the Leibniz test for equality of variance. It tests if the variance spread of score, that is, variance is just like spread of score, how the score scattered around in the group, if they are equal. Then from the value we have here, the Leibniz test, which is the F test, F is value is 1.048, as we can see here. Then the significance level is 0.3. And remember, the significance level we are considering is 0.05. You can see that this 0.310 is actually higher than 0.05 that we used to talk about. So now this is the real value we are interested in, which is the t-test, and that's what gives us the equality of mean. So the t-test statistic measure that is the difference between group means relative to variability, the difference between them. That's the value that we have here as 1.978. Now this df stands for degree of freedom, and is usually the total number. In this situation there are 60. Group A is 30, group B is 30, so total is 60. Then minus the different group. So since we have two groups, that will be 60 minus 2, and that's why the degree of freedom is what? Same, 58. Now this is the significant level two-tailed, 0.053, 0.053 for the t-test that we are talking about here. Now this is the mean, which we have seen before, the mean difference which we've talked about before. So that is to say, mean of group A minus mean of group B give us 4.79617. Then standard error of the mean difference, we also have the value here. So then this also has its meaning, but for this purpose we will just look away. We just come and concentrate and interpret what we need to interpret. So now, so what is the interpretation of this particular table that we are looking at now? So since the significant level here is 0.053 and it is greater than 0.05, so the p-value indicates that the difference in the group means is not statistically different, sorry, significant. That is to say, there is no significant difference between the mean of the group at 0.05 level, at 5% level. So it simply means that the is not strong, and there's no strong enough evidence to conclude that the groups differ significantly in their scores. So because this 0.05 is higher than our significant level, so it's not, we can't conclude because of that. All the evidence are with us now is not enough for us to what, to make our conclusion about that. So at 95% confidence level for mean difference from range, so since the okay, sorry about that. Okay, I'm trying to not to load us with too much information. I think basically that is this. The p-value, although close to 0.5, but is actually higher than 0.05. So we cannot say that the difference between them is significant because of a higher what value of significance, which is 0.053. So that is that for us to be able to interpret the mean. So the next question that comes to mind are, if for example the p-value is lower than this, if the p-value is lower than 0.053, let's say the p-value is 0.03, then we will have been able to conclude that there is a what significant difference. So that is why that significant value is very, very key. So I think that is that about it. We can move forward to the next one, which is the what paired sample. Excuse me. Yeah. So paired sample. So okay, we are done with this. Step to involve in running the pair sample t-test in SPSS. So the pair sample t-test will also come with us talking about correlation, and good enough, we have talked about correlation. So let's see the steps we need to take. We go to analyze menu and select compare means. Then we'll select the paired sample t-test from the compare means drop down menu. Then we'll select the two variables for comparison by highlighting the required variables and dragging them to the pair test dialog box. Then we'll click on OK. So this one seems to be very, very simple and straightforward. Remember, compare means pair sample t-test. Then we'll drop down, select the two variables. So let's quickly do that quickly and see what we're going to get. So we're looking at, since pair sample is always for before and after, so this is score that I've selected for before and after. So we're using these two score, pair test before, pair test after. So this is just a test score given before carrying out using a particular teaching method or before carrying out a particular experiment. So we'll go to analyze, compare. Am I comparing means now? Sorry. We'll go to analyze. Yes, compare means. Analyze, compare means. So look at, okay, very good, pair sample t-test. That's what I was looking out for. So we have the pair sample t-test here. Oh, I'm sorry, I still have something that I've been doing before. So we'll come here. So what am I pairing? I'm pairing test before and test after. So I'll come here, pair one. We have pair test, test before, test after. So that's the pair we're working with, test before and test after. So this one is straightforward. Just click our OK button to see what we're going to have. So this is the test before and test after. So the total number is 60. The mean for test before is 6 points. This is where we have it here. Yeah, mean for, I'm talking about peer sample statistics now. So mean for test before is 64.9801, and mean for test after is 69.6232. So the total number is 2. This is standard deviation, standard error of the mean. Then we also see correlation coming in now. We see correlation coming in, and the correlation here is 0.96. We can see that there is a strong correlation between both of them. Then we have the standard error of the mean, the standard deviation, the mean difference, the standard error of the mean difference lower. Then we have the t-test, degree of freedom. We can see this is where our area of interest is. We are looking at the single tailed at 0.000. So that means this t value is significant at 0.000. That shows that the significance is this does not happen by chance. This did not happen by chance. It's statistically even significant at 0.01 level, which is a very, very strong one for us. A very, very strong one for us. So we have mentioned all the terms. So the interpretation now is the key points now. So to interpret, it means that the test score increased from 64.98, like I mentioned before, 64.98 here, then it increased to 69.62 after, and that suggests an improvement. There's an improvement after the evaluation. There's an improvement, and the correlation also showed to us that there is a high positive correlation indicating that the two set of scores are strongly related. That's another strong point we need to mention. Then the significance at two-tailed, the correlation is statistically significant. Statistically significant. So we can conclude that the high correlation suggests that the participants who scored high or low before the intervention also tend to score high or low after the intervention based on the correlation. So, but if we now use bringing in our t-test value now. So I'm just trying to explain the table one after the other once again. So bringing in our t-test value, then paired sample test table can now say that the p-value, which is 0.00, is highly significant, meaning the increase in score after the intervention or after the experiment is not due to random chance. So if there was a null hypothesis that there is no significant difference, then we can reject it and come and accept the alternative hypothesis that the intervention significantly improve the what? The test score. So that is how we can look at it. So another key note is that whenever we are talking about peer sample t-test, correlation often come in. So the peer sample t-test results indicate that the intervention led to significant improvement in the test score, and this evidence support the claim that the intervention was what? Effective. You can see that is how it is. For those of us, I think I mentioned before that I've done my master's project. I think this is one of the things I do. I try to use a particular teaching method. In fact, I think I did up to three. I did pre-test, post-test, then retention test after 1 week, and I tried to compare some of these tests. Pre-test and post-test, there was significant difference, but post-test and retention test, there was no significant difference. So that means that the teaching method I used was able to help them to retain the knowledge they had even after some weeks. So that is exactly how statistical tool works. So if you have any question, you can reach out to me by email, or you just drop question in the comment section as the case may be. Then, okay, these are just examples that we can use for our own personal study or personal revision. Also another example that we can use for our own personal study or revision. This for peer sample test, and I think this for what? Independent sample. Okay, example of paired. Okay, this is also for paired, right? Yeah, score one, score two, that's before and after. Then also here, before applying, after applying. Then the next point of call is analysis of variance. Now, this analysis of variance is also going to be easy for us because, in my own opinion, it's just one step above t-test. It's also compare means too, actually. But then in this situation, it compare means when we have categorical variables that are more than two. You know, for t-test compare means between two categorical variables. But this ANOVA, that's analysis of variance, compare means, especially the one way, actually, the one way analysis of variance, compare means between more than one categorical variable. So if we have group 1, group 2, group 3, group 4, you can use analysis of variance to compare the means among each and every one of them. So how do you do analysis of variance using SPSS? Go to the analyze menu, select on compare means, select the one way ANOVA, drag the dependent variable from the variable list into the dependent list box by highlighting it and using the arrow drag. Then highlight the independent variable and then transfer it to the factor box. So let's look at that using our data that I've been using. So yeah, I have the cola flavor, then I have the preference score, like how people prefer different flavor of a particular drink. So the different flavor, we have one, two, and three flavor, and I have labeled them here in my variable view as, let me see what I did. I did, okay, flavor A, flavor B, flavor C. That's what I just did for better understanding. So I can now come here and do my analyze. Still on compare means, actually. Compare means, then I'll go to one way ANOVA. Sorry, once again, very easy. So we'll just put our dependent list. So what am I working on here? The preference score. So preference for the different flavor, I'll put our dependent list. Then the different flavor, I'll put them as the factor. Where is the different flavor? Okay, where is it again, please? Cola flavor. Okay, there is it. Cola flavor. particular flavor. Then I can do my options here to select descriptive statistics. If I want to see the mean, median, mode, and the likes, then I'll select continue. Then every other one for advanced, for those of us who are interested in moving advanced, can decide to study more about that. Then we'll click our OK to see what it brings up. So you can see this is one-way ANOVA. As usual, it comes up with the descriptive statistics, which will give us the number of each of the groups, the mean, the standard deviation for each of the group. It will give us everything for each of the group, the minimum, the maximum, which you can use to also get the mode for each of the group. Now, one we are doing is one-way ANOVA. We'll also do two-way ANOVA because ANOVA is also of two type. Remember ANOVA, analysis of variance. So now, if we have the output here, what we need to look at here, we've been talking about all the descriptive things, so we don't have to stress ourselves about the descriptive statistics anyway. So let's just quickly go through the ANOVA table directly. So what are the key terms that we need to understand in the ANOVA table? The first point here is between groups, within groups. When you say between groups, like we are looking at the variability due to the differences between the groups. But within groups, we are looking at the variability within each group due to individual difference. So each group, individual difference, between group, group difference. And we have three groups here: group 1, group 2, group A, group B, and group C in this situation now. So now, sum of squares we have between groups and within groups. So we have the overall variability as 195.52. So when variability is just like the variance of variance, the variance that we know about. Then I've talked about the degree of freedom too, so we don't have to disturb ourselves about that anymore. Then the mean square is calculated as sum of the mean between the group divided by the degree of freedom. So it's just like saying 12.510 divided by 2. So why this is the degree of freedom here is because we have three groups. So we have just 1, 2, 3, so minus 1. That is why it's like that. Then within groups we have total number of each of them, then minus 3, which is the number of the groups, and that's why we have it that way. So 12.510 divided by 2 give us the mean square. This is sum of mean square. Then the mean square is this, divide by the degree of freedom. So we have this. Then this is the F value that we're actually looking for in the ANOVA. That's the F value we are looking for, which is the F statistic. So the ratio of the variability between the groups or to the variability within groups. That's what we're looking for. You can see this F value here is 1.948. For this particular value is actually a large value, and that indicates that there's a greater difference between group means compared to within the variation. So now the next one is the significant. You can see that we have a higher significant value here. So that means it is not statistically, this value of F is not statistically significant. So what else are we going to do now? So the means we are going to state that there is no difference or there is no significant effect in this situation. So let's see how can we put it appropriately now. Let me figure it out. Let me see how we can put it up. Okay, let's say the null hypothesis is that the means of all groups are equal. That is to say, no significant difference. That's the null hypothesis. Then the alternative hypothesis will be like at least one group mean is significantly different. That will be alternative hypothesis. But now, because of this particular value of significance that we have gotten, I beg your pardon, 0.152, which is very, very high to our standard significant value, which is 0.005. So we will now reject the null hypothesis. Sorry, we will fail. We will not reject actually. We have to accept the null hypothesis that there is no significant difference in the mean preference score, assuming this value, significant value, is less than 0.05, then we'll reject the null hypothesis and accept the what? Alternative hypothesis. So that is the way to go. So the F value, remember, indicate the ratio of variability between groups to within groups. Ratio of variability between groups to within group. And this significant value is too large for us to accept that the F statistic is the F value is statistically significant. So basically that is where we are going to um, put a hold on that. So you still have to read more on these things actually. Yes, there's no two ways to it. I don't expect us to just grab it at once. I understand a lot of us must have left statistics for a long time, and some of us have not even been using it. But especially except for those who did their masters, who are doing their masters, may have reason to encounter it. But a lot of us have left school for a long. We are now in the business world. By the time we get to Excel lesson, all those people will be more active. I believe, which will be more interesting to us. But what we are doing now is going to really help our Excel knowledge, because it will help us to be able to know how we can interact with that data, since we understand data and the levels of measurement, especially. So now let's move on to the next one we need to look at, which is okay, this is just one way ANOVA. So we now need to look at two-way ANOVA. So important way about ANOVA, it is important to always report the F value and its level of significant value. And I think I've mentioned it before that um, whenever we are giving our report, we need to know the industry standard. What do I mean by industry standard? How is it being done? How do they do it in your field, in your own field? How is it being reported? Once you know that, then you know the things that you need to what to be reporting. But the most important value in the ANOVA table is the F value and the level of all significant. So now let's look at the two-way analysis of variance. So why do we have to talk about two-way analysis of variance? So now, since we've been talking about the fact that okay, one thing is affecting one thing is affecting one thing, but in real life it's not always like that. Many things could bring about it. For example, the test score or that we've been using over and over, or the blood pressure that I've been using over and over, is not only drug that will actually affect blood pressure. There are many other things. Eating lifestyle, the kind of things you eat will also affect your blood pressure, or how you work, the kind of work you do. Is it a very stressful job? Is it a job that you don't get to exercise your body? Is it a job that is mentally challenging? You are not always physically active. So all these things put together are what will bring about this factor. But then we can look at them one by one, and at the end we also bring them together. So two-way analysis of variance is appropriate when you want to check the effect of two or more independent variables on the dependent variable. You can get what I'm trying to say now. So instead of looking at only study time, you can look at teacher's teaching method to check if a student is going to get a high grade in this test score. So the two-way ANOVA give an overall picture of the difference between the variables of interest, and also shows whether there is an interaction between the two independent variables. So it doesn't just check the effect on the dependent variable, it's also check the interaction between them. Like, okay, if a teacher teaches me well, do I need to spend too much hours of study? That's one thing. Or if I have a very good eating habit, do I need to take too much medication to bring down or to regularize my blood pressure? If I take vegetables, if I take the good kind of food that I'm supposed to take, will it help to regularize my blood pressure instead of what? Taking drug for blood pressure and things like that. So interaction is the expression of the association between two or more independent variables. So all these things, this two-way analysis and two-way analysis of variance will also help us to show if there's actually interaction between some of these things: study hours, teachers teaching method, or eating habit, and use of high blood pressure group. So what we look at is if one of the independent variable has a statistical interaction, it will mean that one cannot just add together the effect of each independent variable upon independent variable. So the effect of each independent variable varies depending on the other independent variable. So in real life, this is what we expect, that all these things will have to be affecting each other. And that is why we must not stop at this point. Even though this course that I'm doing currently is covering this part, there are still many other things we need to look at, like the regression analysis and so many, in fact, uncountable statistical tools we cannot finish at a go. This is what people spend more than 4 years to study. So obviously in 3 weeks we cannot just cover whatever. So this is just a foundation that will help us to move higher and will continue to go upward. So now let's look at the step we need to take to do a two-way analysis of variance. How you can carry out two ways analysis of variance using SPSS. So let's look at this. Let's list the step again. You click on the analyze menu. We select general linear model. Take note, there are two linear models. There is general and there is generalized. So the one we are using is general linear model. Then we'll click on univariate variant option. We'll select the variable of interest and move them to the what, into the appropriate boxes. Take note, you transfer the independent variable into the fixed factor boxes, or you say the categorical variable in this situation. Now then you click on the option button in order to obtain the descriptive statistics. Like I've always mentioned, you can see every statistic that we've been talking about, the descriptive statistics is always coming along. That shows how important the descriptive statistics are. So we also just click continue. It's kind of very simple to follow. So let's look at it quickly using, so I've already given us what we will use to do as our two-way ANOVA. So we have these three columns here: teacher's teaching method, study time, then the student score. So the teacher teaching method, I think there are about, okay, two teaching method. Then study time, there is, we have regrouped the study time. We didn't use it as what's it called, string. We didn't use that, I beg your pardon, we didn't use it as ordinal, sorry, we didn't use that interval and ratio, a scale method. We just use it as categorical. Like, let me see what I used there. Study time, we use, okay, short and long time. So short and long, that's what we use. So then we come to analyze, general linear model, then univariate, select our univariate, sorry. Okay, so we now put our dependent variable, which is the score, two-way ANOVA score. Then fixed factor, we have teaching method and study time. So we have teaching method, where are you? Good. Then study time, come here too. Then options to select descriptive statistics is already selected, so just continue. Then click our OK button here to get the output. Boom. So here comes the output. So we see we have the univariate analysis of variance. So we have the teaching method 1, teaching method 2, study time 1, study time 2. You can see the teaching method 1 is labeled as method 1. Then study time, we have the short and the long study time. So we have the descriptive statistics here for each of the teaching method. So just keep that. So we also have the what? The test of between subject effect. So you can see this is more like, this is more complex than some of the table that we've been dealing with before. So I won't talk much about the what, about the descriptive statistics. We've talked too much about the descriptive statistics. So now what we need to do look at is the tests um, of between subject effect, text of between subject. So this table shows whether the effect of the independent variables and their interaction are statistically significant. So you can see it's all about significance, significance, significant, and that's why we call it hypothesis testing, to test if the interaction or association or the difference are actually significant between the groups. And what this table is doing is just to show us that
to whether the effect of the independent variable, and which ones, the ones that are independent variable, they are the teaching method and study time, the different teaching method and different study time. We want to check if their interaction, you see two things coming in now: effect, interaction. Effect, interaction. Effect on the dependent variable, then interaction among themselves, if they are what significantly um significant, if they are significant, statistically significant. So the key terms we are going to be looking at is the sum of squares. So we have seen all these ones before. Then the degree of freedom, we have talked about that. Then mean square, then the f value and the like. So now the sum of square quantifies um the variation. I think I've talked more and the other statistic density we've talked about. So let's just look at the main effects. So let's look at the study time. Let's start with the study time. So the F value, okay, this is study time 0.482. That's the F value 0.482, and the significant level is 0.490. You can see that the effect of study time on scores is not significant because this is higher than what? This is higher than 0.05. So study time is not significant on test score. Now let's look at teaching method. Teaching method, what's the value? The value for teaching method is um where is it? Okay, this is the one we are looking at here. This teaching method 3.135. That's the F value, and the significance is 0.082. So the effect of teaching method on scores is also not significant, but is close to 0.05 threshold. You can see that it's close to 0.05 threshold, but is not significant. That means that teaching method is a key is a key factor much more than study time. You see that is a key factor. That's based on this research. Based on this research, remember, whenever we talk about data, we're not looking at opinion, because some people want to bring up the no, how can I say that? No, it's not about opinion, it's about data. What the data is saying is what we have to say. At times, you as a data analyst, you'll be seeing data correcting your own mistake, like it has happened to me several times. You see data correcting your own mentality, your own opinion, and you'll be like, oh, I thought it has always been like this. So, and before you know what is happening, data will tell you that no, it has not always been like that. You are just assuming. The real thing is this is how it is. So now, interaction between themselves now. So study time against teaching method. So this is study time against teaching method here now. Study time to teaching method. This is it. So we can see the F value is 4.21, 0.421, and it's also not significant. So the combined effect of study time and teaching method on scores is also not what significant. So you can see in overall, the overall model, the overall models, that's F equals to, this is corrected model now. That's like the overall model, the first one here. The F value is 3.009 and the significant level is 0.038. So the overall model is statistically significant, meaning that at least one factor or their interaction explain variation in score. So you can see when we separate them, there was no significance. When we bring them together, there was no significance. But now the corrected model is now showing to us that at least one factor or the interaction between them explain variation in the score. So to generally interpret the result, we can conclude that no significant effect on score. Study time does not have significant effect on score based on that significant value, the p value. Based on the p value, study time does not have significant effect. So whether students study for a short or long time does not affect their performance. Now for teaching method, no significant effect on scores too, but method 1 shows higher scores than method 2. So let's look at it very well. Method 1, okay, that we can get that from these discrete statistics, short and long. Method 1, you can see mean is 6.9, sorry, 69.5626, but short, long, that is short. The method 1 is short, the method 2 is long, 69.3. Although there is no big difference, but then data shows that method 1, um short method, okay, short method, short study time is higher. But now let's look at it overall as method 1. Look at it now. Method 1 teaching method is average, the total mean is 77, but method 2 is 69 points. So you can see that this one is now different. But when you talk about the long, short study time and long short study time, the difference is not much in the mean, but then one method 1 and method 2, the difference is a little bit more. So now this effect is close to significance, suggesting that method 1 might have a meaningful impact with further investigation or larger sample. So we need to look more on this larger sample, so that we need to look more on we need to do a large sample of this study to be able to know the actual effect of method 1, because from what we are seeing now, method 1 seems to be better. From what we are seeing, method 1 seems to be better. And if you look at this total too, you can see that short study time seems to be better than long study times too. So you see what we're trying to say here now. So statistic is just interesting and funny. It will make you look like, oh, I used to think. No, it's not always like that. Now, let's look at the interaction between study time and teaching method. We have emphasized that there's no significant interaction. So the effect of study time on scores do not depend on teaching method, and so and vice versa. And that's exactly what this data is trying to tell us. So you can see that we still have a lot of work to do to study more on how to understand some of these things. So in conclusion, the model indicates no significant mean or interaction effect, but the overall F-test suggests that there may be some variation explained by one or more factor. So it simply means that before you be able to make this conclusion, or for those of us who are doing projects, we'll say that area of further research. So someone may want to do further research by using a larger sample. Here we use just 60. You can use 120. You can use 240. You can use 480 as the case may be, on and or 500 on and on like that, to be able to get your what, to be able to get your sample. So for today, this is where we're going to end. We're going to reach out to us on the assignment that we are going to do on this particular test, so that whenever we have question, we'll talk about it more and more. Thank you very much for listening. Okay, I think there's a point here. Okay, I think this is just more examples for us, more example for us, more example for us. Thank you for your audience, and have